Hello everyone and welcome to our first video for Chapter 7, which is Consumer Math. So Section 1, we'll be talking about percents. So percent means hundredths. Or in other words, it means per hundred. One way to think about that is that 1% is the same as 1 out of 100. Let's start by talking about how we can convert from a percent to a decimal or a fraction. So to change a percent to a decimal, what you need to do is you need to drop the percent sign and move the decimal point 2 places to the left. To convert a percent to a fraction, write the fraction with the percent in the numerator and 100 in the denominator. Again, because percent means per 100. So when I had like 1%, I put the 1 on the top and a 100 in the denominator, and then you can just simplify that fraction. Let's try problem 1. So we want to convert 70%, 24.5%, and 4% to decimal form as well as fraction form. So starting with 70%, according to our rules, if we want to convert this into a decimal, I just need to take the decimal point and I need to move it 2 places to the left. So in 70%, I don't see the decimal point, which implies that it's on the right. So I need to move it back 2 times. So this is the same as 0.70 or just 0.7. Now to convert it to a fraction, it says to take the percent and write that number in the numerator over 100 and then simplify. So hopefully we notice that we have both of these numbers ending with 0. So I can simplify away one of the zeros and I'm left with 7/10. You also could have just went from this decimal point here and read it as 70 hundredths. Or if you didn't include this 0 at the end, you would have just had 0.7, which can be read as 7/10. All right, the second one we want to do is the 24.5% or 24.5%. In this one, we can see the decimal point, so I know where it is and where I should start moving it. So I'm going to take that point, I'm going to move it 2 times to the left, which means as a decimal, this is going to be 0.245. Now we want to change this into a fraction, and I'm actually going to use the method I talked about where you just kind of read this decimal point and write out what you said. So if I do that, what I have here is 245 thousandths, right? This is in the thousandths place. The other way you would have done it is you would have written the percent on the top over 100, but we don't like to have decimal points in our fraction, so I would need to multiply this by a fraction equaling 1 that will move this decimal point away. So if I multiply this number by 10, it's going to move my decimal point 1 place to the right, so I end up with the same thing I have in blue. Now going back to that fraction, I do need to simplify it. So we can divide the top and bottom by 5. If I divide 245 by 5, I get 49. And whatever I do to the top, I have to do the bottom. So when I divide that by 5, I get 200. Please take a second and try the 4% on your own. So pause the video, change it to a decimal and a fraction, and then come back and check your work. All right, when you change it into a decimal, you take the decimal point, which is on the right, since we don't see it, move it back twice, and you get back 0.04. You can read this as 400ths to get your fraction, or just write your percent over 100. And then I just divided the top and bottom by 4 to simplify this down to 1 over 25. Converting to a percent. So to change a decimal to a percent, move the decimal point, this time 2 places, to the right, and then add a percent sign. So last time we were going from percents to decimals, so we moved 2 places to the left and got rid of the percent sign. Now we're going from decimals to percents, so we want to undo that, so we're going to move 2 places to the right and add in the percent sign. And to change a fraction to a percent, first you change the fraction to a decimal by dividing, and then you do what we have above and you change the decimal to a percent by moving the decimal place 2 places to the right. All right, let's try our first one, which is 0.312. Well, I need to take my decimal point, and this time I'm moving it to the right 2 places. So I move it back 1, 2. So as a percent, this is 31.2%. For 1.23, again, I'm going to take that decimal point and I'm going to move it twice to the right. So this is equal to 123%. And it makes sense that this would be bigger than 100% because this number is bigger than 1. And if you had 1 or like a total value, then you have 100% of the value. So if I have 1.23, I have more than 1 or more than 100% of the value. And let's look at the fraction 4/5. I'm going to show you 2 ways to do this. So the first way, like it was stated above, is we could divide this. So divide 5 into 4. 5 doesn't go into 4, but I can add a decimal point, and 5 does go into 40 8 times. So 4/5 is equal to 0.8. Now it looks like a decimal, so I can just move that decimal point twice to the right to show that this is the same as 80%. Another thing you can do is if you can figure out how to make the denominator of your fraction 100, then the percent value will be your numerator. So I can change 5 into 100 by multiplying by 20. And then whatever I do to the bottom of my fraction, I need to do to the top. So it's like I'm multiplying by a fraction equaling 1. When I multiply this out, I now get 80 over 100 as an equivalent fraction to 4/5. And since I have this 100 in the denominator, and my fractions can be written, or I'm sorry, my percents can be written as a fraction over 100, I can see that this is the same as 80%. Again, it's the number in your numerator when your denominator is 100. Problems involving percents. When writing a percentage statement in symbols, the word of becomes multiplication, and the word is becomes an equal sign. Also, we must change the percent into decimal or fractional form so that we can do our math. So for example, if you were asked, what is 10% of 30? Anytime you see the word what, this is going to be your variable. So I'm going to write n. Is becomes an equal sign. 10% of becomes multiplication. And anytime you have a number, you just bring it down. So I can figure out what 10% of 30 is if I just multiply 0.10 times 30. There's also other ways that you can translate your percent equations. I believe people like to do it with a fraction where they have like amount and base and percent and 100. If you learned that before, that's fine. This is just an alternative way. I think it's fairly easy to just notice that the word of becomes a multiplication symbol and the word is becomes an equal sign. And then you can solve this equation. Now, sometimes your variable will be one of these two values, so you might need to divide rather than multiply. But once you have it set up as an equation, it's pretty obvious what you're supposed to do. Okay, let's try to apply this idea to this word problem. So exercise 3. My friend is a great sale shopper and coupon collector. On a recent mall outing, she found a blue sweater with a selling price of $77. She had 2 coupons to choose from. The first coupon is $15 off any purchase of $50 or more, and the second one is 20% off any regularly priced item. Which coupon is a better choice so that she gets the better discount? Okay, well, with coupon number 1, she's going to save $15. For coupon number 2, she saves 20% off. So I need to figure out how much money 20% of $77 is. Or in other words, what is 20% of 77? And now we can use those translations that we learned above. So remember, what is going to be your variable? Is going to be your equal sign. Anytime you see a number, you write it down, but it's helpful to change your percents into their decimal form. You can write 0.20 or 0.2, it's the same thing. Of becomes multiply, and when you see a number, you write it down. So all we need to do is we need to multiply 0.2 by 77. And if you do that, you get back 15.4 or $15.40. So the better coupon would be coupon number 2 because you save 40 cents more. Now we're asked, how much did the sweater cost with the better discount? Well, the better discount was coupon 2 where we saved $15.40. So we just need to take the original price of the sweater and we need to subtract off the discount, which gives us $61.60. Part C says the sales tax in her county is 7.75%. What is the total cost of the sweater, including the tax? Well, I need to figure out what 7.75% of the new price of my sweater is. Or what is 7.75% of 6160? So take a second and pause the video and try to translate this into an equation and solve for your variable. All right, so the tax is going to be $4.77. In your calculator, you probably got 4.774, but I just rounded to the nearest cent since we're dealing with money. So now the total cost of the sweater with the sales tax, I just need to add these two quantities together. So I need the cost of the sweater with the discount plus the sales tax, which is going to give us $66.37. I want to point something out in this problem, so I'm going to back up to parts A and B. You could directly jump from the $77 to the $61.60 without having to do 2 steps if instead of figuring out what 20% of $77 is, you figured out what 80% of $77 is. Because think of it this way, if you're saving 20%, then that means you're only paying for 80%. If you're paying for 80%, then you want to know what is 80% of 77, and that'll tell you exactly how much money you will have to pay. So n equals 0.8 times 77, and if you do that in your calculator, you get back 6160. So that's helpful if you're actually shopping in real life and there's a sale. Let's say you're at Target, our favorite stores, and like a pair of pants is 35% off. That means you're saving, out of paying for 100% of the pants, you're saving 35% of it. So you're paying for 65% of it. So you could multiply the price of the pants by 0.65 and it'll immediately tell you how much the pants are going to cost you. So it really just saves you that one extra step of having to subtract from the original price if you multiply by the percent you're paying for rather than by the percent that you're saving. Exercise 4. A clothing company reported that it had to cut its workforce back to 65% of what it was last year. If it has 78 workers now, how many did it have a year ago? Okay, so it has 78 workers now after it cut its workforce back to 65% of what it had last year. In other words, we want to know 78 is 65% of what number? Because the 78 people I have left were 65% of the people I used to have. Or the 78 people left working at this company, I should say, is 65% of the employees that used to work at that company. Now let's translate this. So again, every time you see a number, you write it down. Is becomes equals. If you see a number, write it down, but if it's a percent, make sure you change it into a decimal. Of becomes multiply, and when you see the word what, that implies your variable. So I have 78 equals 0.65 times n. Or I'll write it a little more compactly. So these two numbers are being multiplied, so if I want to solve for n, I need to divide by that coefficient. So in your calculator, take 78 and divide it by 0.65. And if you do that, you should get 120. So the company had 120 workers last year. This is a good problem to look at because every other translation we've done so far had both of the numbers on one side of the equation being multiplied. Let's go look up at the last problem again. Notice when I translated this, it was two things being multiplied. When I translated this one, it was two things being multiplied. But in this case, when I translated it, I had one number on the left side of my equation and one number on the right side of my equation. So in order to solve for the unknown, I actually needed to divide. And these are kind of the only options you're going to have when you're doing these problems. You're either going to be multiplying the numbers together or you'll be dividing the two numbers. Worst case, if you can't figure out how to translate it, you can just try to use common sense and do all the different options. So you could try to multiply these numbers together. If you do that in your calculator, you get 50.7. But this problem says that they had to cut back its workforce. So how could I have had less people last year if I've now decreased the number of people I have? I should have had more last year. So that one doesn't make sense. Then you could try to divide. If you do 0.65 and you divide it by 78, you get back a really small number. You get 0.008 something. So it's not even a whole person. So common sense, that doesn't make sense. But when you divide the way that we found from our translation, we get back a number that actually makes sense in this problem. We get back a number bigger than 78, which we should get back because we supposedly had more workers last year. All right, percent increase or decrease. How do we find this? Well, the first thing you do is you find the amount of the increase or the decrease. Right? Either you've grown or you've lost. Then you make a fraction where you put either the amount of the increase in the numerator or the amount of decrease in the numerator. So that number you found in step 1, but you always divide it by the original amount. So if the problem specifically asks for the amount of increase, then you know you're doing this. Or if they specifically ask for the amount of decrease, you know you're doing this one. But it also might just say what's the percent change. So you need to determine if there was an increase or a decrease and then plug it into the fraction accordingly. Now, step 3 is you change the fraction into a percent. So you'll be left with some fraction, you can divide it and get a decimal, and then move your decimal point 2 places to the right. Problem 5. Billie Eilish's popularity has grown dramatically in the last year or so. In November of 2018, she played to 1,100 people at LA's Fonda Theater. In 2019, she performed at the Forum to 17,500 people. What is the percent increase in her audience attendance? Okay, so we know we're doing an increase, so let's figure out how much her audience has increased over the last year, just between these two shows. So at her most recent show in this problem, there were 17,500 people in attendance compared to the show in November where there were 1,100 people in attendance. If you subtract that on your calculator, you get 16,400. So there was an increase of 16,400 people from the show at the Fonda Theater versus the show at the Forum. Okay, so step 2 of percent increase or decrease is to write the amount of the increase, which for us was 16,400, divided by the original amount. Well, our original amount was only 1,100. So I expect this to be a huge percent increase, like way, way more than 100%. Okay, if you want to start simplifying, you can get rid of the zeros that match at the end of your fraction, divide what you have left, and you get 14.909, and that continues. So I'm actually going to change this to say approximately. Now I want to change that into a percent because I was asked for the percent increase, not the decimal. So this is, again, about 1490.9. I'm just going to say this is roughly 1,491% or 1,491%. So a absolutely gigantic percent increase in the number of people attending her concert. Exercise 6. A designer bag was all the trend 2 months ago. One store in particular ordered 75 purses to keep up with the demand. 2 days ago, the store said they only keep 30 in stock at all times because demand has gone down. What is the percent change in the number of purses kept in stock at this store? I'd like you to pause the video and try to solve this one on your own and then come back and check your work. All right, and you should have gotten a 60% decrease. So again, we take the original amount, which was 75, and we subtract the new amount, which is 30. So we have a decrease of 45 purses in stock. And then you do the amount of decrease, which was 45, divided by the original amount, which was 75, which gives us 0.6. Moving that decimal point 2 places to the right, we end up with 60% decrease.